Hello everyone, welcome to the lecture on applied IoT. I will be your lecturer Nipunana Singha. In this lesson, or in this subject, applied Internet of Things or IoT, we will be taking a deep dive into the theoretical parts of of um, of the applications that we can have of IoT in the real world. We will be looking at the marketplaces and how we can use IoT to build value chains. We will be looking at applications that are already there in IoT in different sectors and industries of the economy. We will be looking at how to apply IoT solutions for problems we have. So in applied IoT, we will be mainly learning how we can have IoT solutions not only in a small scale like a smart home, but in a large scale industrial platform. We are looking at overall picture of IoT, where everything in the world, where the things are connected to the internet. So everything will be connected to everything, and how we can from the connections to collecting data to processing it and giving a productive outcome. We will be looking at all of these in this lesson. The theoretical part of IoT and how IoT can be applied in the real world. Before going into a deep dive, right, let's go to the content page and let's see what we are looking at in today's lecture. We will be first and foremost taking an introduction to IoT. And then it will be followed by examples of IoT devices, and then it will be followed by examples of IoT applications. This part is a small repetition or a refreshment from the IoT class before, and by now I think you will be familiar with the sensors, actuators, processing capabilities and networking, the technical parts of the IoT, right? Maybe if you are not having a deep dive to it, maybe you will be able to understand, or maybe you have researched on those along those subject lines. So in this first 3 points, we will be basically refreshing that memory and taking a small introduction to what is IoT. This will be followed by introduction to applied IoT. Then we will try to understand characteristics of IoT. These characteristics will be the main components when applying IoT for large scale solutions. Then we will take introduction to machine, and we will take examples of machine to machine communication, right? And finally we will be looking at machine to machine and Internet of Things, where what is machine to machine communication or machine to machine systems, and what does it have to do with IoT, and how IoT can be used to increase the productivity of machine to machine, and how IoT has taken over the sector of machine to machine communication. So we will be taking an introduction, and we will be looking at the overall picture of using IoT in a mass scale. On it could be from industrial level to cities to large scale buildings, structures, and maybe large scale agriculture or anything. So before going to all that, right, we will to understand what are the sectors, what are the things that IoT is applied to. We will first go to taking introduction to IoT. This portion, as I told you before, the three points of introduction to IoT, examples of IoT devices, and examples of IoT application. This is a refresher. This is a repetition of the IoT class itself. So I will be going, rather than taking a long time to discuss and everything, we will be quickly going through these examples and applications. We will, along the way, we will be talking about what are the sensors and those things that are available in these examples or devices, what are the actuators and those things that are available, so that we will take a good refresher and we will understand what is IoT before applying IoT in the real world. So, introduction to IoT, let's look at a definition of IoT. The Internet of Things, or IoT, describes the network of physical objects. This part of the sentence is the most important. The Internet of Things, or IoT, describes the Internet of the Internet of Things, or IoT, describes the network of physical objects, here in this case things, that are embedded sensors, actuators, processing ability, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. So, by the definition itself, we understand it's a network of physical objects or hardware components. These hardware components or these devices or systems contain sensors, actuators, and processing ability. On top of that, those hardware components will be working with software and other technologies. It could be cloud technology, AI, EO, and other networking technologies which is there, right, for the purpose of connecting and exchanging data. So for the purpose of collecting and exchanging data, so these sensors would be, or these physical objects or these devices would be collecting data to collect and exchanging them. For that, they will be using the network with other devices and systems over the internet. So all these devices will be connected to the internet, or at least an intranet, to give an outcome, either to collect data, process them, and to give a productive outcome. So this is a basic definition of IoT. In the main components that should be there is the network of physical object or network of hardware components or devices, network of devices, right? That is one part that is needed to be covered, because when talking about IoT, there's always a network involved. There is always a hardware component involved, right? And they are embedded, those devices or those physical objects are embedded sensors, actuators, processing ability, software, and other technologies, right, for the purpose of connecting and exchanging data. This is the other part that is important when defining IoT. These devices are networked for the purpose of connecting and exchanging data with other devices or other physical objects and systems. These systems are also mainly made out of other physical it could be from actuators and so on. We will look at the examples while we are going through to give a outcome. And they are connected over the internet or a wide area network. If the users wish to have an intranet, it would be an intranet, but they will be networked. Most of the time IoT is more than 90% of the time is connected to the internet. So this is IoT. So let's refresh our memories to see what are IoT devices in respect to this definition we have given. So we are looking at examples of IoT devices. In this case, we will be looking at here in the definition, these physical objects. These networked physical objects would be the IoT devices. The very first example is cameras. Cameras are one of the obvious choices and most famous example of IoT application or IoT device. So the camera itself is the physical object or the device. This device is an embedded device where we can find sensors, actuators and processing ability alongside with software, especially with image processing software inside it. So let's first look at what is the sensors that are being used in cameras. The main thing for the sensor is a image sensor. All cameras have it. The sensor allows light to enter in, and it will take in light and process it to give us a picture on what's it looking at. So that means to process that data of light which is coming into the sensor for the image sensor, there will be the processing ability in the camera, and there will be software to support that processing ability. There will be image processing software inside. Addition to that, there will be actuators in these cameras. According to the definition, these physical objects. Actuators will move the image sensor from one position to another. You have seen this in security cameras, that there will be small actuators inside, like small motors or the devices to move the actual position of the camera to have maybe a 360 degree of view. So that means there's an actuator component to it as well. Then of course networking. We all know security cameras are networked into one centralized location to take in the data, right? You can look at those data from one control panel, one screen, and from one location you can monitor the data. When these networked cameras are connected to the internet, you will be able to look at these look at the pictures which are obtained from these cameras from any location in the country or in the world even. We can see this application, we can see that these smart cameras, which are mainly used as baby monitors or to monitor pets when the owners are not in home. These small cameras will have the ability, even those small cameras will have the ability to connect to the internet and transfer that images to the cell phone of the needed party, so that the person who need to see the picture at all times will be able to see it. This networking would be done through either cabling or directly connected to the Wi-Fi or any other network method which is convenient and which is able to carry large amount of data, because image data is a large amount of data at any given point, especially if you are providing HD quality images. So the network, so there's a network component to it, right? And there's a physical object to it. So we have seen that it is an embedded device. There are sensors, actuators, processing ability, right? And we have seen this connected to the internet to provide the functionality. What are the applications of this? Applications of these IoT cameras, the main thing that comes to mind is surveillance. Surveillance in the form of security mainly, right? So in a let's take a scenario where there's a warehouse and there's a control center or a place where the security staff is located, but the warehouse is a big building. So to keep an eye on the surroundings at all times, these cameras can be set up in a network to get that information. Owners of the warehouse doesn't even need to go to that location to have a look, because they can connect to the internet and take the security camera images directly into their phones or to their computers. If they want, and surveillance could come in another form. If they want to see what is happening to the stored objects, let's say food is stored inside or grain is stored inside that warehouse, they should keep an eye on whether animals are getting in or out. Not only the security aspect of theft, there's a quality aspect to it, so they need to surveil that product all the time. To do that, they can use cameras. Cameras that are fixed with infrared lighting will help to surveil this 24/7, even at night time where there's less light. And when that data is connected to a network and that particular network is connected to the internet, or those devices are connected to the internet directly, people who need to look at that location can look at that location or surveil that location at any given time through live streaming from the internet. Same scenario is applied to baby monitors. Same scenario is applied for small cameras in homes. Same scenario is applied for cameras in the street for security. Same scenario is even applied for small cameras that are there to monitor pets when the owners are out from their house. So you can see that there are different applications, and these applications of IoT device, these different applications are able to achieve its goal of providing surveillance or providing visual of a thing that is needed to be viewed from a remote location by connecting this physical object, in this case the camera, to the internet. Thus, this is a good example of Internet of Things. Think of a factory and every machine of the factory needed to be surveilled at all times. Think of a hospital, and nurses should have the ability to monitor critical patients at all times, but we cannot have staff aligned in front of each critical patient at any given moment. But one nurse could check multiple patients at the same time, in real time, when there are cameras set up. If you take the applications are endless. The main application would be security, but there will be more other applications using cameras. So this is one of the main IoT devices. What is the next? Let's see the next example. It is for temperature monitoring and control. So for temperature monitoring and control, while I was talking about earlier, mainly you can see these things in Sri Lanka in hotels and large scale buildings, and even storage facilities. Think about places like Highland. They need to store their yogurt, milk products, ice cream, butter, those things in cold temperatures. So temperature control is very important. And when you go outside of Sri Lanka to countries in the closer to the northern hemisphere, let's say Canada, United States, England, Europe, or Japan, Korea, China, these countries have a, when you go towards the north side of these countries, the harsher the winter gets. So countries that have winter needs thermostats or temperature, the ability to monitor the temperature and control the temperature inside a home, inside an office, inside any building where human habitation is there, is very important. By having a thermostat or a temperature monitoring tool inside the house, people living inside the house will be able to have a constant, comfortable and healthy temperature. It won't be too cold in the winter time. The heaters can be adjusted accordingly and temperature can be maintained. Same goes for summertime. The ACs can be adjusted accordingly and maintain a proper comfortable temperature. If you take the Middle Eastern countries, thermostats are used to control these temperatures by adjusting looking at the thermostat, and we can use the thermostat to control the ACs. These temperature monitoring tools are not only used in places where human habitation is there, but it is also being used in warehouses, as I gave you examples for products that need cold temperatures, and even extreme versions of thermostats can be used in production line. Think of steel manufacturing, cement manufacturing, or thermal coal power for producing electricity. Temperatures of those locations should be measured to keep in a safe value and in a constant value. So extreme versions of thermostats are used in those locations. So thermostats or any device that is there to either check the temperature, to monitor the temperature, should then have a sensor to monitor the temperature at real time. This is something that doesn't only apply to a house or a closed place, maybe a warehouse or a factory or large scale office building or a hotel or something like that. There are thermostats located outside, right, from the weather department, or any other service that provides weather information. If you go to the internet right now, you can type in any location of the world and see what is the real-time temperature of that location. That is also something that is done by a temperature monitoring tool. If you take why is that important, for Sri Lanka, the temperature stays at a constant around 30. It will be always around 30, either 28, 29 or 31, 32, around that area it stays. But if you take winter countries, right, in the it will differ by 10 to 20 degrees Celsius in a day. The wind speeds will change the temperature as well. So when going out in the winter time or when going out in the summer time, it is safer and necessary to understand the temperature outside, so they can have necessary protection, maybe putting on heavy winter jackets in the winter. If in the summer or in a hot country, maybe carrying an umbrella or either carrying water with you for dehydration, or not going out at all, postponing the event or not going out at all for safety reasons. So temperature monitoring devices are also very important, and the sensors that are being used in that is mainly the temperature sensors. When those monitoring tools are connected to the internet, that data can be extracted, right, and through cloud computing, real-time information of data, temperatures of outside and inside can be changed and exchanged, right. In going into the future, I will give an example of how thermostats are used for for automation and how IoT application is done. For now, as a device, of course, this has a networking part to it, right? That is how we are able to type in any location on Google and find out the temperature, real-time temperature of that location. It is through a temperature monitoring tool. We can find out the temperature, not only the temperature, we can find out the humidity, we can find out anything. And that is done by IoT devices giving out real-time data, physical objects that can monitor the environment, giving out that data in real time to the internet. So that's a part of Internet of Things. Then of course, another very common IoT device is the lights. Light bulbs in itself, light emitting object itself, are actuator, but of course, when connected to the internet or when connected to a intranet where there are sensors to see the intensity of the light, right? These smart devices can be switched on when daylight is low, and that information can be taken again from weather monitoring tools outside, and so on and so on. We can control these lights from our smartphone, right? Or we can control these smart lights from sound. We can clap and the lights will turn on, which is also in those cases it will provide an energy efficient solution where lights doesn't need to be turned on at every time, can be turned off, and that system is a self-containing system. Nobody needs to attend at all times. We have seen this applied in cities as well, for street lights. When the sun goes down, that can be monitored and the lights can be turned on. So smart lights, there are many applications, and mainly it's there for the comfort of a human being as well as as well as a good productive energy efficient method of using it's an energy efficient method to preserve energy, so that light bulbs can be managed in a way to work efficiently as possible with the least amount of electricity being used, right? So overall, uh, lights are part of IoT, right? I will. There are some examples. If you go to next example, let's see. Okay, so there's motion sensors and contact sensors. We will talk about light sensors with motion sensors and contact sensors. How a productive outcome can be given. That is also one aspect to it. We will see how those things are applied as well. Also, one thing to remember, lights can be used as actuators to indicate something as well. Let's say the temperature of some area is going very badly. The temperature monitoring tool figures out that this inside the factory, the temperature is getting high due to this machine is malfunctioning. In the control room, a light can switch on and indicate that something has gone wrong. We have all seen those films where a red light goes on and says something is going severely bad. So these devices, again, individually is not that effective, but when connected to the network is effective. So first we will look at these devices, then we will go for step by step for application of these devices. What will happen when networked to the internet, how we can extract data, and how we can give a productive outcome. If you go to the next example, right, it is the motion sensor. As a IoT device is another commonly used device or instrument to measure the motion or the distance between two objects, situations like that. These are used mainly, the picture what you see over here is mainly used for security purposes, to see if anybody is trespassing or any movement is taking place. Again, these devices can be used in maybe in industrial workplaces to see if the machines are working and moving correctly, using as a proximity sensor as well. Like in vehicles, we have warning lights coming up for proximity sensors, even in machinery. So these devices are commonly used in IoT networks. The processing capabilities are either embedded inside the device, or mainly when it is connected to the network, it will pass on its collected data into a control system, where that data will be processed into information for either the people who are working in the factory, to be used to say, okay, this machine is malfunctioning, it's not working correctly, or in a vehicle to say that there's another object or a car nearby, slow down or brake, or in a home to detect whether a trespasser is coming in through a window, or some from a location just jumping into the house. Those things, every scenario and more scenarios can be covered through motion sensors. If you talk about the sensors that are being used inside this device, there are infrared sensors, so ultrasonic sensors, microwave or topographic sensors can be used. maybe a cluster of them or just one sensor depending on the requirement. So one of the main things that needed to be checked when selecting IoT device as a solution for a particular problem, we have to check the sensors are sensitive enough or powerful enough, the range of the sensors, the capabilities of the sensors are up to the standards or up to the parameters that we are trying to cover in our solution. Similar to motion sensors, or we can say proximity sensors for in this case, there are contact sensors. Contact sensors are mainly used to see if two objects are either touching each other or not. Best example would be a door or a window. Any place that is needed to be closed and sealed, maybe a air-conditioned environment, we can check the doors or the windows are closed. Applications could be go from warehouses to office buildings, to hotels, to give a efficient air conditioning and energy saving method. Factories can use these factories who are using heavy machinery can use these contact sensors to see if the machinery if they are needed to be in contact with each other, it is doing so or not. If you take robotic arms, they may have contact sensors to see if like sensitive functions like welding is taking place correctly. Of course, as you can see, those locations, those places, humans cannot actually go near. It is not safe, so it is better to use contact sensors. Think of another example would be in a railway station. We have seen that two trains are getting joined together, and that particular environment is not a safe environment for a human being to go close and check. Though we have seen that what is happening in Sri Lanka is the same, but we can use a contact sensor. If we have a contact sensor on either side of the train where the joint is, we can actually, we would not need any visual aid or going closer and inspections. We can check the contact has been made correctly or not. Then after a safe connection, maybe a human can go and do secondary inspections. So there are applications that we can use contact sensors as well. Another example, networking this contact sensor with, let's say, in the last example we talked about lights and temperature control units. So let's say if a door opens up, we can network this and smart lights so that when the door opens, the lights would come up. The temperature control unit can turn on the air conditioning or the heating because it senses that a human has entered the building or entered that room. So that is a small application of IoT devices working together to give a efficient and productive outcome. Then of course we have another famous example. It's smart plugs. Smart plugs, if you take properties of smart plugs as an IoT device, there are smart plugs that can actually monitor the amount of electricity that is being consumed, which will in a long term will be able to collect data and process to see how much energy is actually consumed, maybe in a household or maybe in a factory, and you to then after that, looking at those data or information, people can make energy efficient solutions and the decision making process can actually make energy efficient solutions, it will be better for the environment, it will be better in a financial sense as well. And these plugs can be controlled from your either your smartphone or your Alexa. These control centers you can see below can be used to control them, or it could be voice activated, sensitive to sound, or again contact sensors or motion sensors would detect that a human has arrived to that location, so they can switch on those connectivities. These plugs are used because they are able to control the flow of electricity in a smart manner by connecting to a network. These plugs are used to bring irrelevant or old devices which cannot be connected to IoT to be connected into IoT. Think about your day-to-day table fans or old light switches or machines that are actually does not have IoT part to it. Maybe they are legacy devices, right? But though they were legacy devices, that doesn't mean that we can add components to it and make it a part of IoT. Smart plugs or plugs that are controlled remotely, or plugs that can be connected into a network, can help to support bring legacy devices or devices which are irrelevant to IoT into the IoT environment. Think of a situation where a large scale manufacturing facility where there are let's say 1000 people working in that factory, and each person has their own machines. It could be a garment factory or some a phone assembling factory or something like that. Then smart plugs can be used to see if all the device, when the factory is shut down for the day, they can check whether all the devices are correctly turned off and no electricity is consumed. If something is not properly turned off, they can switch it off from the plug itself, thus preserving in safety when the factory is in shutdown mode. There will be no electrical instruments running throughout the night, maybe things like heat guns, which is a threat to safety because fires can occur. So these plugs can be used in that manner as well as emergency stops can be performed remotely. So there are many applications. So smart plugs, though seems like a simple device controlling electricity mainly, it can be used, and the main component or the main feature that we can highlight is these smart plugs can be used to bring in legacy devices into the IoT environment. Then we have smoke detectors. Smoke detectors is of course is a thing that is a must-have by law mainly in commercial buildings, hospitals, hotels, storage units, any large-scale building, including even apartments, are required to have smoke detectors. This is mainly for the health or the safety of the people who are living in that particular building. So smart smoke detectors may have couple of sensors to detect different types of environmental changes. It won't be only smoke, maybe it would have temperature, it may have ability to detect particles which are not particularly emitted from from smoke or a fire, but particles that are harmful for a human being. These are also a option for smart devices, because there will be a whole plethora of sensors which will be there, networked to each other and networked into a centralized control system to pass on the data as quickly as possible to take correct decisions. Um, when coming we will when coming into applications, we will look at how smart smoke detectors can be used in different environments as well. Right now we are just taking a refreshment on what are IoT devices and what we can use them for. Let's look at the applications in future examples. This is just to refresh our memory to see what is IoT. So air purifiers. Air purifiers are again something that it's a device which has another set of sensors, including network and processing with it to carry out its performance. So what are the sensors? One of the, like the smoke detectors I talked about before, air purifiers have the ability to detect, smart air purifiers would have the ability to detect the the purity of the air, the particles, what are the particles in the air in its surrounding. That would be one of the main options a smart purifier would have. Then again, the purifier can be connected into the internet, and the purifier can take data through the internet to see if outside environment is polluted or not, because especially in countries which have high rates of pollution, examples would be China and India, they have a uh, live feed of these pollutants, where they are, where the wind is carrying them, where would be they next, and how much pollution is out there as a percentage or as a particle per million. So sensors are there, and those sensors detect these things, and those sensors are connected the to the internet, making those sensors a part of IoT, and that particular data is passed into these air purifiers to activate them or to keep them deactivated. So uh, people who are having, especially who are having health conditions regarding their lungs, can use these air purifiers, or places like hospitals, ICU, especially ICU units of hospitals, can use these air purifiers to when treating their patients. As well as there are sensors to detect these air purifiers as filters inside them. So there are another set of sensors to detect whether the filters are in which capacity that they can filter, because after some time they will lose their power of filtering, so they would need changing, and that particular point also can be measured through sensors inside the air purifier. And as IoT device, it would then send a notification to the owner's phone or the application which they are using to monitor the air purifier. Then we will go to the next example. There are when talking about IoT devices, we cannot omit control centers. All these motion sensors, contact sensors, plugs, or if you take cameras, the temperature monitoring, lights, everything in a house, a building, a manufacturing plant, or any other application, in a smart home, in a smart city, in a smart country, anything which uses IoT would have an interaction point between the human being and the IoT system. And that interaction point may come across as a control panel, it may come across as a smart home device which is given by Google or Amazon, right? We have all seen Alexa ads. We can give voice commands to control the lights, the TV, and so on and so on. That means it's a IoT system in action. The control center can be in the form of a smartphone. You will be able to control the lights, the locks, everything in your home through your smartphone or your Alexa. That means that it is connected. Those devices are connected in a network to work together to give an efficient outcome. So these control centers, if you go into industrial scale control centers, there are fully equipped rooms with all the machinery and of course networking and processing power. When coming into control centers, there will be three main points. One, there will be a network element. It would have network connectivity to all the IoT devices that are under its monitoring. That is one of it. It would have a network connectivity to the internet to share that data or to share that processed data. Then there is also in control centers, there will be processing power. All these simple IoT devices as motion sensors, contact sensors, or even cameras, smart lights, they won't have a large quantities of processing power, either CPU, GPU, and other capabilities as RAM and storage as well. They won't have a lot. So those data will be transferred into the control center. When I'm saying control center, don't only think about these pictures. Think about a scenario, a control center where there are a lot of people, there are a lot of monitoring the screens, there are a lot of processing powers, data centers, and those things. A best example you can think of is when launching a rocket. When launching a space vehicle, you have all seen SpaceX launches, and you have seen how the control center looks like. So that control center is monitoring millions of data points which are being released from the rocket itself while traveling. It would communicate with in using wireless technology to the ground centers, and that data will be passed on to the control center in real time to detect if there is any problems or any adjustments needed to be done. Right? They are also control centers. When you have the ability to see the speed of the rocket, the distance the rocket traveled, when you are watching a SpaceX launch on YouTube, in live conditions, you are looking at data which is being lively broadcast through a IoT system. You have access to it. You have the ability to see it. So control centers or control units comes in all shapes and forms. These two examples which you can see here are mainly there for smart homes, but industrial applications look a little bit different. They would have separate monitoring rooms. Let's say there is a complex, a housing complex where there are thousands of apartments, houses there. So there will be a monitoring station or a small monitoring room just to check the smoke detectors, to keep an eye on the locks, to keep an eye on the people who are entering those premises, to take care of the packages and the mail that has been coming. So a control center in that sense could be any size. It would have any kind of processing power. It would have any kind of input. As I told you, even your smartphone could be a control center with processing power, which would be able to access a IoT device. Air purifiers comes with their own application, which means it will connect to the internet, and through the internet the owners of that air purifier will be able to take the data that they need, right? So control centers or the control units where a human and a IoT device interact. So as I was telling, there will be three main components. Networking would be there in a control center. Processing ability, storage, RAM, and everything would be there for doing to have the processing ability. Then the third point would be there will be a method of human interaction, either from a screen, or either voice control, or either even an alarm bell or alarm light going off, any kind of. So there will be a human interaction. Humans will be visually able to see what is taking place in the IoT environment, right? So control centers is a very important part of the IoT environment, right? There will be, as I told you, there will be a component, a hardware component where human interaction takes place. When saying interaction, back and forth, the humans will be able to detect and to see if the plugs are switched on or off, and the humans will be able to switch them on and off manually as well. So in IoT environment, a control unit or a control system application, it could be a web-based design, is very much needed. Looking at simple IoT devices with maybe a single set of sensors or actuators, let's look at some IoT devices which use multiple number of sensors, actuators, and processing units. As well as we can say these are embedded IoT devices. So let's start with a good example in a industrial environment. Those are robot arms. We have the first picture when talking about robot arms which comes into our mind is car manufacturing facilities, and today in vehicle manufacturing, a robot arm for either placing a panel on the car itself, welding, or applying glue, applying paint, everything is done by robot arms. And so one of the main key striking features that we would see is before looking at the sensors, it would be the actuators, the motors and everything that runs this device, the claws or the movement between X, Y and Z axis in the three-dimensional plane. Of course, that means when you have a device, when you have a machine that moves around in a three-dimensional plane, that means there are sensors to recognize the location in space, right? There would be sensors to understand how far the arm has moved, and the location in 3D space where the arm is. This can be achieved by having sensors when coming into movement. You can use either gyroscopes, or you can use accelerometers, small sensors like that, to see the movement, and then you can look at sensors which are specifically there to find the angle that the device is in the three-dimensional space. So Again, not only that, when we are talking about these arms, we always have seen them working in unison together. That means these devices are networked together. So when one arm is working on one particular action, the other arms are aware of it and will not interfere, so that there will be no problems. That means there is software working on it. There's a software component working with this robot arm, and there is a processing component working with this robot arm. So as a IoT device, this as a IoT embedded device, this has a hardware component in the sense in the sense of actuators and sensors. There's a processing component to it, and there's a networking component to it. And of course, as you have seen in videos demonstrating how these robot arms working together to build in manufacturing plants to build a vehicle, it is pretty obvious that they are connected to the internet and uses cloud computing to do the necessary processing of the data. These clothes could have sensors that we talked before. We talked about motion sensors and contact sensors, which both can be implanted on these sensors to see how close the claw is to the actual object itself, and so on and so on. So that means this is not a single it's not a single sensor or actuator working. It is a embedded system, networked together, embedded hardware devices working together in a network, which is connect that particular embedded network of hardware, sensors and actuators is connected to the internet itself, passing data through and processing data, which is fed to not only this robot arm, which is fed to other robot arms working with it to carry out the manufacturing process. So a whole manufacturing line can be created, which is one of the most complex things, and a lot of processing power is needed. So cloud computing is a part of it, where it will be the most efficient by using shared resources, and this whole device in that way becomes part of Internet of Things. From industrial application, let's move to the application that is on your home, a smart fridge. So in this you can see there, of course, the first thing that catches our attention is the screen, and we have examples of what the screen can access, including weather, music, and videos, or any articles on cooking and recipes. This means that this fridge now becomes a part of IoT when connected to the internet. It can deliver recipes, it can scan what are the food and beverages available inside it, and can check whether the temperature is correctly maintained or not. That means inside this IoT device there is a temperature monitoring and control unit built in. So it becomes an embedded system. There's a smart light inside. When the door gets open, you can see the lighting, or you can use a camera which is inside the fridge. No need to open the doors, thus saving energy, and it is efficient. So there are many single-use IoT devices embedded together to make this particular IoT device, which is the smart fridge. Let's look at a innovative scenario. When the owner of the smart fridge may be in the office and coming back from the office, he or she needed to look at what's in the fridge or what they need to buy from the market while coming home. Rather than they were unable to make a list, they can just connect to this device through the internet, switch on the lights inside, switch on the camera inside, and check what's inside the fridge itself remotely. So they can judge what to buy and what not to buy. It's a convenient application. It is a productive, convenient application, and of course that is for a small scale application for a smart home. If we want to make it a bigger application, these can be fridge can be a smart food storage unit or a food storage warehouse, which could give the same ability to monitor the food which is inside. So in that particular case, the whole warehouse itself becomes a embedded IoT device, or the devices which are in the fridge itself, the cameras, the lights, and the sensors to detect whether the food is gone bad or not, can be applied to a larger scale scenario. That is, so that would be another example. So from a smart fridge, we can go to another IoT device, which is the Roomba vacuum. Of course, we have seen plenty of videos, cats getting scared or pets getting trampled with, and this, of course, when coming into sensors, it has proximity sensors. It would have sensor. It would have a plethora of actuators which will work to sweep and vacuum and give the movement to all directions when needed. That means there are several motors which are running in conjunction with each other to carry out the sweeping, the vacuuming, and the movement, change of position, change of location of the vacuum itself. The vacuum has the ability to self-charge. The vacuum also has the ability to activate when the time is given, and the vacuum can be controlled by a simple application. And that application controls this vacuum through the internet. So this the Roomba vacuum is a part of a smart home, and it's a good example of embedded IoT device, where a set of sensors, actuators, processing power, and software works together to give an elegant solution. Smart locks. Of course, we have seen these locks, smart locks, which sometimes are not even connected to the network itself, but the options, the solutions that it can give, the elegant solutions that it can give when connected to the internet is immense. So when somebody keeps the fingerprint, it can go through a database and identify is it a correct fingerprint or not. And if let's say a person who enters the house using the fingerprint or the passcode, a message can be sent to the owner of the house saying that, oh, this person has arrived in the house. When this smart lock is networked to the other IoT devices inside the house, when the door opens, if it is night time, the smart lights could come up. The temperature monitoring and control units can switch on the AC or the heater. Surveillance cameras can show the person who has come into the house. Another option would be a doorbell with a video, right? And that can be accessed through the internet. So several applications can take place when this device becomes a IoT. Then again, let's take another example. This time again we are going for industries, and this time it is the hospital industry. Smart hospital beds. Of course, when we talk about hospitals, especially when we talk about ICUs and smart hospital beds, means a bed that would have all the sensors that is needed to monitor a patient remotely. It could be cameras, pressure monitors, to see the blood pressure, to see the heart rate of the patient, to see the temperature of the patient, to see the stability, maybe to see if there is erratic movement of the patient. If in that particular sense, motion sensors can be used. The patient or the patient would have the ability to call the nurses or the hospital staff in an emergency in real time. There will be saline monitoring, oxygen monitoring devices also. There will be then actuators can control the position of the bed from flat to a little bit upright if needed, so on and so on. As a whole, one device, it is a very complicated embedded IoT system. Of course, those data can be fed into the network or to the internet, and direct real-time information can be transferred to the nurses who are monitoring the patients, and the doctors also who are involved with the patients. So the reaction time, if medication is needed or special attention is needed, the reaction time is reduced, thus giving opportunity for the patient to get treatment very quickly. If the doctor, if the smart bed can, let's say, monitor the temperature of the patient throughout a day and create a report, and send a email with the 24-hour report of the temperature of that patient, a doctor can go through it and make judgments if they need to change medication or not, things like that. So the applications, it could be a single IoT device, it could be a network of IoT devices, a system of IoT devices which is connected to the internet. When we are talking about smart hospital beds, the applications of sensors and actuators are endless. Then again, we can talk about another IoT device, virtual reality gaming. Of course, when coming into virtual reality gaming, there are few components that we use, and these components have sensors and actuators to give the experience of virtual reality, right? So let's start with the control units in his arms, right? There will be motion detectors, there will be accelerometers, gyroscopes, there will be touch sensitive capacitance in these controllers, and that data will be fed into the processing unit, in this case the PC, either through wireless or wireless connection or through wired networking, and that data will be processed, and visualization and sound effects will be created as output, and from his from the output devices, from the screen to the headsets, the feeling of virtual reality as a visualization is given to the user. So again, the applications themselves. So another portion would be, this person who's playing a virtual reality game could be connected to the internet, and they can use cloud resource to have a much better experience, or they can connect with other virtual reality players together in a virtual world through the internet itself. So as you can see, the IoT device or IoT embedded device could be a simple thing like a light bulb, and a very complex thing like a smart hospital bed, or a robot arm, or a smart fridge. Let's look at another 3 examples before we go into the application of IoT, right, using the internet and everything. Let's look at another 3 examples quickly, and we can go to the applications. So there's health monitoring devices, of course. We talked about smart beds, but sometimes there will be patients who would need monitoring of heart rate, pressure throughout the day. So a smart watch can be used as a health monitoring device, which will be connected to the internet and which will give out warnings through to your phone, or for a person who's taking care of you, they can receive the information that they need, and so on and so on. A smartwatch itself is a very good IoT device. It has a screen to input data and to output to input commands and output data for the user to see. Plus there is a whole lot of sensors to check your blood pressure, heart rate, your location, position, and geoposition to see if you are walking or not, the accelerometers, and so on and so on. So this is a very good example of a very compact IoT device, or IoT embedded device with a ton of options as IoT device. Then of course the one of the most, and I think the most crucial IoT device of all time, this would be autonomous driving vehicles. Autonomous driving vehicles have every single sensor that we can think of. It would have gyroscopes, accelerometers, motion sensors, contact sensors to see if the person is actually touching the wheel or not, the driving wheel or not, right? You can see it in Tesla. You can't always drive without touching the driving wheel for a significant time. From that, there will be Wi-Fi connections, geolocation, pressure sensors to see the pressure of the tires, temperature sensors to see the temperature of the batteries. There will be actuators in the form of motors display screens, so on and so on. Of course, we all know the application of Tesla vehicles, where it will be connected to the internet and it will share its driving data with other similar vehicles, so that the driving experience would be better. There will be processing involved, cloud computing involved, but each driving vehicle, each autonomous driving vehicle would act as a IoT device, or embedded IoT device itself. Of course, there are other vehicle in Tesla vehicles. The main sensor is the camera sensor, and that it has the processing. The car itself has the processing ability to process those images and understand and do image recognition to understand and the surroundings. But there are other options in other brands or other vehicles which use maybe LiDAR to understand the surroundings. So there are different sensors and different devices which is networked together with processing power, software, and the connection to the internet to make this IoT device. Yes, in the future, even today, not the future, even today, a car, or autonomous car, or even a semi-autonomous car is a part of IoT. Right? So one of the Google Maps, we can see the traffic. How can we see the traffic? The data is collected from somewhere. So other people, either other cars which are connected to the internet, or through people who are using Google Maps in devices which have accelerometers, or some situations like that. Right? When all that data is fed into a cloud and processed, they can show where the traffic is and where the traffic is not. So there are from those applications, from autonomous driving cars to weather monitoring devices, this would be the most simplest example. We have all done it. We check the temperature. We just type on the internet, what is the temperature of this location? We get that. What is the wind speed? We get the live wind speed. Is it raining? We can check. Right? If it is a country where winter is, we can check the temperature outside. We can check the real temperature, and we can check the temperature that feels like according to the wind and the humidity and those things. Same for a place where there's a lot of sunlight or heat. Right? And these data will be shared through the internet in real time. An individual person or individual house or factory does not need to have a weather station, a personal weather station. A single or several weather stations around a city or a region can cover all the data that is needed by the people who are living in that region. So again, you can see the sensors. The sensors are there to monitor the wind, the temperature, the humidity, and other weather related factors. So these are examples of IoT devices, right? So these are examples of IoT devices, and we talked about these IoT devices and what they do when they are connected to the internet. So we can next look at examples of IoT applications. Again, I will reiterate that by now you should know what are IoT devices, what are they used for, what are the sensors in them, and how we can use how we can build a IoT device to address a certain problem. So this is a refresher of to say, okay, these are IoT devices out there and these are the sensors that is being used by them. And now we will look at again examples of IoT applications. So we are going to look at examples of what these devices, when connected to the internet, how these devices can be applied to a scenario. How when these devices are connected to the internet, that data would be passed through to other IoT devices to give a positive, productive, efficient outcome. The first application of IoT. So the example over here is a very simple example where very few components of IoT devices connected through the internet working together to build a comfortable environment for human beings to live in. And there will be many applications. We will look at it one by one. But before going to looking at the application, what is taking place here? So we have talked about the weather monitoring devices. So these weather monitoring devices would collect data and send that data into the cloud or into the internet. In the cloud, it will be processed against other incoming data, maybe from satellite images about the weather, maybe from other stations located hundreds of kilometers away, to take a full picture and predict through the set of previous information they have. They will compare and they will theorize how the future weather could be. And that information can be passed on to our main device that will control the temperature of any location or any room. It would be the thermostat or the temperature controller, and that from that the temperature, the thermostat or the temperature control unit can then compare the data of the temperature which is outside that building and the temperature inside the building and adjust the air conditioning or adjust the heating system. Similarly, these weather monitoring devices could check how much particles are in the air, is there any pollutants in the air, or if there is pollution in one area, if they can detect the wind and predict where the pollution, that smoke would travel to. That data could be also passed through the internet through a smart air purification system. Then the air purification system can adjust its settings to control the volume of air taken in and purified at a given time to give the most productive outcome to the people who are living in that particular room, house or environment. So let's look at the very first set of examples, the very first line which goes through here from the weather station, from IoT weather monitoring devices through the internet and cloud, processing that data, giving into a temperature controlling system. Then that temperature controlling system would adjust the air conditioning. This example is a very good example of the application of a IoT system. So as you can see, when these are all connected together in a network, these devices talk to each other, share data through the internet, and give an outcome by themselves without human intervention to keep the temperature of that room in a suitable amount for people to live in. So think of other scenarios where this application can be applied, right? So the one that you see is a home where the weather stations would check the wind speeds. If the wind speeds are high, it will be a little bit cooler. If the wind speeds are not there, it will be much hotter. If the temperature of the intensity of the sunlight is high, the temperature becomes high. So these data can be fed into the thermostat, including the outside temperature. So then the human touch can be happening on that thermostat, where humans can adjust the temperature to what they need, and then that data compared to the temperature data which is coming from the weather monitoring IoT devices, they can compare it and do the necessary adjustments in the air conditioning system to maintain the temperature inside the home as needed. Now think of again, as I told before, in Sri Lanka this is not a very much applicable situation, because the temperature is always similar. But countries which are subjected to winter or harsh heat conditions, if you take countries like United States or Canada or European countries, they are subjected to winter, and the temperature variations from daytime to night is drastic. We are talking about around 20 degrees of difference, especially in autumn and spring. So to maintain a healthy temperature inside a room, IoT devices can be a great help. Think of Middle Eastern countries, which they are naturally very hot environments, very dry, very hot environments, and they need to maintain temperatures for human habitation inside buildings. But if you take the nighttime and daytime of those countries, there will be at least 15 degrees or 20 degrees Celsius difference between daytime and nighttime. In that case, the AC, the air conditioning speeds, the fan speed, or the amount of air that is being run through the system, or the amount of air cooled in that system, have to be adjusted accordingly, because the AC output, air conditioner output in the daytime cannot be the same in the night time. In winter countries, the AC will go off, but then the heating systems will come on. Then the heating at the night time cannot be same as the daytime. In daytime, there will be a little bit of sunlight, so there will be room to reduce the heating of the particular room or building or house. But at night time, it will be extremely cold, and it would be necessary to increase the heat of the heating system on that house, right? So if rather than humans checking all the time, or when you are sleeping getting up, and if it is too cold or too hot, switching on the AC and or switching off the AC, these devices can work together in a networked environment to give a good outcome. It would be healthier for humans who are living there. Same with the purifier. But let's take this again, the temperature control system with the weather outside, the thermostats and the AC or the heating systems, right? Let's take let's take an application away from homes. These can be applied for factories, where sometimes factories need to produce large quantities of heat to make their product. Thermostats can be used to monitor that heat, and and to see if those machines are creating too much heat respect to the outside temperature, either to cool them down and stop from destroying them, the machine itself. Or large amount of people are working in a factory. It could be a garment, it could be a we have all heard of Foxconn, where Apple iPhones are made. There are hundreds of thousands of people working at those places. So information which are fed through weather monitoring devices can be communicated into thermostats to control the temperature on vast scales, to help the human beings comfortably work in those factories. Then again, think of a factory where ice cream is made. Think of a factory where milk is processed. Temperatures have to be low to make those things. And if let's say a factory is manufacturing ice cream in a tropical or a Middle Eastern or a country where near to the equator, where the heat is a lot, the thermostat should know the weather outside to efficiently control the temperatures inside, so the product will not go bad. So the applications, you can see now the applications are becoming endless. If you take another main application of again this weather monitoring stations connected to the internet, passing that information to thermostats, and those thermostats are passing that information to either air conditioners to cool, or either to heating devices to heat the environment. We have storage units. Storage units, there are special storage units for some products where the temperature must be perfect at a particular level. Otherwise, either the food product or the product that is being stored will go bad. Wine cellars will come into mind. There should be a particular temperature, or otherwise the product will go bad. Ice cream, yogurt, other milk products, dairy products comes into mind. Meat comes into mind. Large scale storage of these items would need cooler temperatures. Now this is a good example for this IoT application taking place in Sri Lanka. Sri Lanka is a hot country. The temperatures are hot, it's very humid. So that means the air conditioning systems should have the ability to communicate with weather monitoring devices outside to maintain that temperature from the storage, either food or anything going bad. So how could that help? Why does a person need to have this IoT system applied into their storage? One would be quick decisions will be made, right? If you take again the examples of storing ice cream in let's say in a Middle Eastern country, the temperatures between night and day is so much, the thermostat should be adjusted throughout the day. If it is needed to be manually adjusted, it would be hard. Or let's say in Sri Lanka it's a rainy day and the temperatures go down a little bit, then do we need to we have to adjust manually the temperatures just of the storage unit to match the temperatures that we need. Or otherwise, sensors inside these air conditioning devices or thermostats, which are again IoT devices, have to make decisions by themselves. Again, not only that application, think of the cost, the savings, the efficiency of using of energy. Rather than the air conditioning or the AC units or the cooling units running 24/7 at a high pace, consuming a lot of electricity, when the temperature in the outside gets high, only those things get activated, and when the temperature goes low, the activation rates get lowered in a fridge or mass scale fridge or air conditioning units. The savings, the financial savings could be a lot. The energy savings, if you take, today we are talking about global heat, the earth is heating up, the temperatures are going up, we could feel it here in Sri Lanka as well. So in conservation of energy is a big topic today, and to conserve that energy, these IoT systems can be used. Think of ACs being used in buildings. In rainy days, it is not that much needed. In rainy days, if you have AC working on a let's say a large AC plant working on a building in Sri Lanka, the amount of waste in energy would be high because the temperatures are low and there's no need of a high amount of AC. So those things can be calculated and communicated between these IoT devices, thus giving an efficient outcome. The owners of the building will receive financial benefits, basically lower electricity bills. Then think, same goes to hotels. So in a hotel, the most important thing is the customer satisfaction. If you take in that perspective, if you go to a very heated area or very hot area, and the hotels there does not provide proper cooling ability, then the customer won't be satisfied. If it is a rainy day or if it is winter and the heaters are not performing well, the customer will not be satisfied. So it is necessary to use IoT devices in hotels to maintain temperatures at suitable ranges where the customer feels comfortable. If you go to a hotel and you have to complain every time the AC is too much, the AC is too low, there is no AC, it will become, the customer will become agitated and they will not recommend the hotel to any other person, thus losing business. So these are value adding points. Thus we cannot see it from our own eyes, but these are value adding points to industry. And another application of controlling the temperatures would be in hospitals. Patients who have undergone surgery, or patients that undergo surgery, or patients that need pure air, or would need comfortable temperatures to recover, right, will get immense benefit from these devices. Patients patients that require these temperature control systems to stay in healthy conditions, right? When you are sick, you are a little bit weak, so if it is too cold in the room, right, it would be hard for the patient. It would be because the patient have to fight the sickness plus the cold. So if there's a thermostat controlling it, and that thermostat have information from outside where the weather is monitored, whether it's too hot or too cold, and the temperature is maintained by processing that data and maintaining the air conditioning throughout the duration of the patient's visit constantly, it would be a great help to the patient to recover. Apply that from a ward to a ICU ward, and air purifiers can come into play as well. So these applications these applications are endless, and they are value adding, right? No hospital wants to hear that I was in this hospital, especially like if you take private hospitals. If it's the word of mouth, then that's how value is added, right? If a patient goes out from the hospital and says to other people, I will never go to that hospital because it was either too hot or too cold, the temperature system is so bad, nobody will visit that hospital who hears that. So that means business will go away. So applying this IoT system to a hospital again adds value to the hospital. Same scenario for any other application as well. Temperature control compared to the outside temperature, either it's the wind, it's the humidity, it's the clouds, it could be it could be either winter or raining or anything taking place. That information is important to determine the temperature outside, and that outside temperature can be fed into a thermostat to control the AC unit efficiently. Whenever a AC unit or a heating unit, something which consumes a lot of electricity, is controlled in a manner to give a positive outcome plus efficient outcome when coming into usage of electricity, the benefits, especially for large scale applications like office buildings or large scale hotels, even hospitals, even private hospitals, there will be incentive to use them because there will be energy savings. And the applications towards global warming would be positive because less energy that is being used, less fossil fuels needed to power up these systems. So in every perspective, there will be a value adding point to these as well. So we are looking at a single example of how few IoT devices, not a lot of IoT devices, few IoT devices working together to give a good outcome. Let's go to the next example, right? Let's go to the next example and see how these IoT devices when connected to the internet, can be a very powerful tool. In this example, we are going to talk about fire alarms or fire extinguishing systems, fire monitoring systems, which are mandatory in making today's construction industry, and how IoT can play a crucial role, or how IoT applications can improve a fire alarm system. So if you first and foremost, let's think of all large scale buildings, including office building towers, large hospitals, hospital buildings, storage areas, large storage buildings to large hotels, apartment buildings, uh, even theaters, movie theaters, and those places. Every single building or construction that we can think of, where a lot of people are there, even homes today, will require fire safety. This is something must, and when designing buildings for large amount of people, fire safety or having devices to detect fire and to sound alarms is very important. Now, and it is regulated. That means that there is no alternative. There should be fire detection systems in those large scale buildings, shopping malls, again theaters, hospitals, hotels, whatever a big building you can think of, apartment buildings, luxury or not, it should be there. So now we can look at how we can apply IoT to make a more productive, efficient fire extinguishing system, right? Let's go through the process quickly and see what will happen. If you talk about the regular system, there will be alarms going off, right? A smoke detector will detect smoke and the alarm will go off. Then somebody have to be informed about it, or somebody who hears the alarm have to go and call the fire department and notify the authorities, or a person should see the fire itself if nobody hears the alarms, or the alarms or if there is a malfunction in one alarm in a particular area when the fire takes place, someone else have to visually see the fire to warn the others in the building. Maybe there will be alarms going around, then they will hear, but if they didn't hear those alarms, that would be a problem. So when coming into notifying the authorities themselves, there should be either building managers or somebody on duty to take necessary actions. But if we are going to use a IoT system, how could it be? How could the actions be? The actions or the reaction to the fire would be automated, would be swift, and it would be helpful for others as well. Let's see what are the factors or elements that will be working together to give a IoT system when coming into managing fires in buildings. So first things first, a fire occurs inside a building. Maybe it's due to electrical shortage, it could be chemical, it could be a old school fire which started by a candle or something like that, right? The smoke will be detected from a smart smoke detector, and the smart smoke detector would also have heat sensors to detect how much heat is emitted from the fire, right? From the amount of heat, the readings, from the amount of heat readings from maybe one or two smart smoke detectors around that particular location, or let's say if it is a building, the building floor, that data can be fed into a cloud system or a processing system, and they can make assumption or take data on at which particular location is the fire taking place, and they can detect how bad the fire is, the intensity of the fire, is it spreading quickly, if couple of if like the amount of alarms that detecting heat becomes increased, that they can detect where the fire is moving, if the fire is moving throughout the floor or is it moving from floor to floor. Those things can be detected. The smoke itself can be read if there are particles that is very harmful for human beings. Is it a very thick smoke or a less dense smoke? If it is a less dense smoke, it would be better for the humans, easier for the humans who are staying in that particular area to retreat from that area. But if it is a dense smoke, then the actions would be different. All those information will be networked into either from wireless networks or through cabling, or otherwise it will be relayed into the processing area or the control units. So that means alarm bells will go off for the control in the control unit, right? Depending on the scale of the building, it would be a large factory or a small scale apartment building. The Anyway, there will be a person who will be in charge of that control unit at a given time, right? The humans will be alerted. While that is happening, right, the system can process the data itself and switch on the sprinklers, not in the entire building, if it is a small fire in that location itself, right? Because if the sprinkler system goes off around the building, other properties could get damaged, like laptops and electronic devices could get damaged, valuable documentation could get destroyed from the water. So that can be controlled through IoT system. And needed sprinklers, the intensity of the sprinklers can be increased, decreased, or new sprinklers added from the data we are getting from the smoke detectors, because they will be keeping an eye on how much the fire is spreading, right? The At least if the smoke detectors on the exact location of the fire is destroyed, the smoke detectors nearest to the fire can give that data, and this is in real time. So the sprinkler system, it will be automated. It will the smoke detectors will send the data to the processing or the control area. The control area will process those data and switch on the sprinklers in one go. And that all that data collected from the smoke detectors and the process data from the processing units or the control system will be fed into the internet. what how can we use the internet then in IoT system to take quick action? Owners of that building can be notified instantly, right? Instant messages can be sent through the control through the internet to those owners of, so they know what are the next steps to be taken. Everybody in that building will can get notifications through to their phones or any other way, saying that there is a fire at this particular location or this particular floor. Please evacuate quickly as possible, But if some areas needed to be avoided, those information can also be given in that notification, and those notification can be kept will be pushed according to the in real time according to the data which has been produced by the smoke detectors. Then again, those all those data about the fire, about the location and all those things can be fed into the fire department response units and everybody. So these response units or the fire department will have the data which they desperately need to tackle the fire, how intense the fire is. If there are poisonous gases emitting from the fire, the fire brigade could be prepared when coming to that place. If the fire is taking place in a tall building in a higher floor, they will bring the equipment which is needed to tackle that particular height. Those vital information could be passed quickly towards the fire department in real time, rather than calling back with the people who are in that particular location to get this information. So the firemen or the ambulance services or whatever which is needed can come quickly and prepared to tackle the fire. While that is taking place, if let's say it's a factory and which is on fire, and every person who's on the factory has a health monitoring system, that particular set of data can also be fed into the internet, right, by cloud computing. Relevant parties, it could be hospital ambulances which are needed to be dispatched, can keep an eye on, or even the owners of the building, people who are in the control center of the building, can keep an eye on the people who are either in good health or bad health. In a situation where there's a fire, of course there is a high possibility of people getting hurt, and those people can be identified, their locations can be identified using IoT devices, and quickly they can get attention, right? So overall, the amount of value that is being added, the amount of is immense from a IoT application towards fire control in a building, right? So for example, we talked about again the sprinkler system only taking place for the needed area. Thus other let's say it's a 30 story building, and it's all office buildings. There are laptops, there are documents, those are very valuable for the business to continue. If this fire is only at let's say 20th floor, and if the sprinkler system can switch on and like take off the fire, that means the sprinkler system in other areas doesn't need to switch on and destroy those electronic devices. So that adds a value. It is efficient, the efficient way of controlling the fire. Then again, think about a scenario where it's late at night. Let's say it's 3 a.m., it's 2 a.m., and nobody's in the building itself. So a fire may start from an electrical leak or something, and it will continue for hours without anybody noticing. That will not happen when an IoT device is in action, because it will be networked to the internet and to a network where that particular information about the fire will be given to several parties. So human error itself, right? It could be human error, or because if the office premises or that factory is closed for the day, there will be less humans available, less eyes on the floor. So these alarms and these things needed to be connected to a network. Otherwise there will be no quick action. So IoT application will create quick action. That is a value adding thing. Think about, the quicker the action to a fire to turn down the fire will be the most productive and financially sounding. So if somebody asks for a IoT application for fire alarm systems, it is easy to recommend a fire alarm system, right? Even if you take the human lives perspective of it, right? If the data can be taken, some person collapsed due to hardness of breathing because of the smoke. In, let's say, the fire is at on 20th floor, on 25th floor this happened. Sometimes he might be alone in that particular floor. If there's an alert generated through IoT system, and that alert could go to the IoT system, could be from that person's phone, smartwatch, or even through a smart camera which can do image processing to understand if a person is standing up or fallen down. That information can be fed through the internet to the relevant parties for quick action to go and help. So in that case, of course, the regulations say that we have to have fire detecting system for safety. We can add value to that safety. We can make it more active, more efficient, a quick responsive. It's a responsive way of handling the situation. It would be economically sound to use a IoT system to control the fire, especially in large compact areas where buildings are next to each other. Think of a city like New York, like where buildings are next to each other, and fire control is a really important thing. Think like cities like Tokyo, where again a compact city, right? So there are the application, IoT application to a single issue would be much efficient than using the traditional just smoke alarms and those things, where the human error is taken away, quick response is generated, there will be processors to handle everything, if a IoT system is applied. So we looked at a single, in this example, we looked at a single IoT application being applied to where the temperature control, that particular single application, IoT application, is used in different scenarios, either homes, factories, storage edge, or commercial buildings, office buildings, hospitals, hotels, theaters, so on and so on, right? Now we looked at a single scenario where IoT can perform better, IoT solution can perform better rather than the legacy method of handling. So again, I have put some notes here. So the data that is been circulated through the internet would be data on the fire, which is again the intensity, the smoke levels, and those on the content and the particles of the smoke. The location of the fire can be also given to the relevant parties, is when sending the messages to the fire department, health of the people that are in that location. Not only in that location, if a fire is starting in that location, when it is connected to in a full IoT environment, if it is a smart city itself, the people who are in buildings next to the fire also can get alert, so they know what is going on. If they need to go to safety, if they feel uncomfortable, they can react as well. So in a smart city scenario where everything is connected to a IoT system, this it would be much more efficient and much more safer. So again, the data would be speed and intensity of the fire and information informing the people nearby. So again, a single scenario for a single scenario, and in this example we look at a single scenario and the IoT application to that scenario, right? In right now I think we have covered around 2 hours. So in the next lecture we will be looking at another two examples where again a single IoT application or a single IoT set of devices which will be detecting which would be detecting weather and those properties of the weather can be applied to different scenarios. We will be looking at an example like that, and then again we will be looking at several IoT devices applied in several different locations, maybe for different things or could be for similar things. But again we will look at how these applications takes place, and how value is created, or how it is efficient and better to use IoT devices rather than legacy devices or unnetworked devices, right? We can talk about the automation part to it and so on and so on. So we will talk about those two examples. Then in the next lesson we will take an introduction to applied IoT, right? We will look at the topics, we look at the characteristics, and we will take an introduction to machine to machine communication, and how machine to machine communication and IoT works together or takes place, right? What is the we can look at the difference of IoT and machine to machine learning. So that we will take the introduction to those things as well in the next lesson. So moving forward we will learn about the marketplaces, how value is created, and so on and so on. But in this first set of lectures I want to refresh your memory what is IoT and how IoT can be applied, and how a small introduction how IoT is IoT application, and how that is much better, which means value adding in a financial sense. It's value adding to use IoT systems. So in the next lecture we will look at the rest of the examples, and we will move to the introduction of applied IoT and machine to machine communication. Okay everyone, thank you.